Hi everyone! So today's video it's putting it all together. So everything we saw in the last 3 videos, we're gonna make it as a whole. Um, so to summarize, when you request a website in your browser, you first need to go from the URL that you have to an IP address. So you would add, like your browser would ask to find the web server IP address with DNS, and then when you get that IP address, you would connect to the web server. So your computer then talks to the web server using the HTTP protocol that we saw before, and it will return HTML, JavaScript, CSS, images, text, whatever, which your browser then uses to correctly format and display the website to you. So there are also a few other components that help the web run more efficiently and provide extra features. So in these other components, so the first component we'll talk about is load balancers. So when a website's traffic starts getting quite large or is running an application that needs to have high availability, one web server might not be able to do the job by itself. So that's when load balancers come into action. So they provide two main features: ensuring high traffic websites can handle the load, and providing a failover if a server becomes unresponsive. So when you request a website with a load balancer, the load balancer will receive your request first and then forward it to one of the multiple servers behind it. The load balancer uses different algorithms to help decide which server is best to deal with that request. So we get, for example, it uses, for example, the algorithm round robin, which sends it to each server in turn. So, or weighted algorithm, which checks how many requests a server is currently dealing with and sends it to the least busy server, and many more algorithms that you can look up if you want to. So load balancers also perform like periodic checks with each server to ensure they are running correctly, and that's what we call a health check. So if a server doesn't respond appropriately or doesn't respond to a health check, the load balancer will stop sending traffic until it responds appropriately again. The next component that we are going to see is the Content Delivery Network, or CDN. So a CDN is a geographically distributed network of proxy servers. It can be an excellent resource for cutting down traffic to a busy website. It improves the website load time as it allows to host static files across servers around the world, such as JavaScript, CSS, images, videos, and host them across thousands of servers all over the world. When a user requests one of the hosted files, so before having a CDN, all users will request in from one server or one web server. Instead of this, the CDN will work out where the nearest server is physically located and sends the request there instead of potentially the other side of the world, making everything like way faster and smoother. Next component is databases. So often websites will need a way for storing information for their users. And web servers can communicate with databases to store and recall the data from them. So databases can range from just a simple plain text file up to complex clusters of multiple servers providing speed and resiliency. So, in general, what we come across all over the web is this type of databases: MySQL, MS SQL, MongoDB, GraphQL, Postgres, and many more. Each has its specific features. Another component that is that we can find all over the web is a WAF, or Web Application Firewall. So this WAF sits between your web request and the web server. When you want to send a request to a web server, your request goes through first the WAF, so the Web Application Firewall, and then it goes to the web server. However, first thing first, so its primary purpose is to protect the web server from hacking or denial of service attacks. So it analyzes web requests for common attack techniques, whether the request is from a real browser rather than a bot. It also checks if an excessive amount of web requests are being sent by utilizing something called rate limiting, which will only allow a certain amount of requests from an IP per second. If a request is deemed a potential attack, it will be dropped and never sent to the web server. So how web servers work? And what is a web server? We've been talking about web servers since earlier. And in fact, a web server is a software that listens for incoming connections and then utilizes the HTTP protocol to deliver web content to its client. The most common web server softwares that are Apache, Nginx, IIS, and Node.js. A web server delivers files from what's called its root directory, which is defined in the software settings. For example, Nginx and Apache share the same default location of /var/www/html in Linux operating systems, and IIS uses this, so anetpub and /www root for the Windows operating systems. So for example, if you requested this URL, which ends with picture.jpg, it would send the file that is in the /var/www/html/picture.jpg from its local hard drive. And then we have virtual hosts. So web servers can host multiple websites with different domain names. To achieve this, they use what we call virtual hosts. The web server software checks the host name being requested from the HTTP headers and matches that against its virtual hosts. So virtual hosts are just text-based configuration files. If it finds a match, the correct website will be provided. If it doesn't, or if no match is found, the default website will be provided instead. So virtual hosts can have the root directory mapped to different locations on the hard drive. For example, 1.com being mapped to var/www/website1, and 2.com being mapped to var/www/website2. There's no limit to the number of different websites you can host on a web server. There's also something else that we have to know is static vs dynamic content. Static content, as the name suggests, is content that never changes, Like common examples are pictures, JavaScript, CSS, etc., but can also include HTML that never changes. Furthermore, these are files that are directly served from the web server with no changes made to them. While dynamic content, on the other hand, is content that could change with different requests. For example, a blog, on the home page of the blog, it will show you the latest entries. If a new entry is created, the homepage is then updated with the latest entry, or a second example might be a search page on the blog. Depending on what word you search, different results will be displayed. So these changes to what you end up seeing are done in what is called the backend with the use of programming and scripting languages. It's called the backend because what is being done is all done behind the scene. You can view the website's HTML source and see what's happening in the backend, while the HTML is the result of the processing from the backend. Everything you see in your browser is called the front end. And then we have scripting and backend languages. There's not much of a limit to what a backend language can achieve, and these are what make a website interactive to the user. So some examples of these languages are PHP, Python, Ruby, Node.js, Perl, and many more. These languages can interact with databases, call external services, process data from the user, and so much more. A very basic PHP example of this would be if you requested this website, so HTTP whatever / example.com/index.php name equal Adam. So if index.php was built like this, here we go, it would output the following to the client. Hello Adam. So it gets the name first from the GET request, and then it shows that name back. So you'll notice that the client doesn't see any PHP code because it's on the back end. So this interactivity opens up a lot more security issues for web applications that haven't been created securely. So let's go and do the quiz. So here we go. We have different contents here, and we have to put them into order. So the first thing would be to request tryhackme.com in your browser. So once that is done, the first thing we can do is find the IP address. So it will check the local cache for the IP address, and if it's not there, it will check your recursive DNS server for address. Then this recursive DNS server, if it doesn't have the IP address, it will go query the root server to find authoritative DNS server. Then once after the root server and so on, so root server, TLD server, it should find the authoritative DNS server that advises the IP address for the website. So once that is done, the request will pass through a web application firewall. Then the web application firewall will analyze the request, and if it's deemed okay, it will pass it through the load balancer, and then connect to the web server on port 80 or 443, depending on if it's HTTP or HTTP secure. And after that, the web server receives finally the GET request. When the web server receives the GET request, it will talk to the databases to get the data needed, and then send everything to your browser, and your browser renders the HTML into a viewable website. And here you go. That was it for today. Thank you for watching, and until next time. Bye!